Well, good morning, everybody. Welcome to Climate Whiplash. I'm Curt Stager. I'm a paleoclimatologist or climate historian from New York State, and very happy and honored to be here to talk to you today. Basically, what I'd like to do with this presentation is introduce you to a long-term view or the full long-term story of climate change by using examples from history, climate history, long-term views of how climate changes naturally, how that kind of information might inform us as to what we're doing today. And I'll just start out actually by sort of showing what the talk is not really about. Here we go. Yes, I think when you came here, if you have in mind that climate change is only about politics and the cultural divide around the world and about what's happening right now, I would assume maybe you've come in here thinking I'm going to take one side or the other in the argument like this. You may recognize some of these figures. And just sort of so I can get a sense of who's in the room here today, if you don't mind, I'd like to do a show of hands and just ask the question, who in the room here would say you pretty much agree with the idea that climate change now is real, the global warming is real, and that it's mostly due to humans? Okay, and how many would take the other side that it's, yeah, maybe it's happening, but it's not due to us? And how many would rather not say in public, either one way or the other? Okay, good. Usually groups that I talk to, it's about a 50-50 split, so I'm used to that. I'm not going to try to get into this kind of thing about the ins and outs of that. I do want to reassure you that people in my field, in climate history and climate science, basically the arguments are over and done with to the point that we just take this as a fact, and we've gone on and continued the research, and what I'd like to do is show you today what's been coming out of the cutting edge of climate research now. Even to the point here where there's a technical term now being used in the field that acknowledges the geological scale of the impact that we're having on the world as human beings now, sort of in the same tradition as breaking up Earth's history into epochs and naming them after climatic or biological events of the past, like the Pliocene and Pleistocene and Eocene epochs that you can sort of identify in the rock and fossil record. Well, if you add up all of the effects that people are having in the world now with our huge numbers, our great technology, and our interconnectedness, I've made a partial list here of the extinctions of species and moving other species around, changing the very face of the landscapes, and of course adding our greenhouse gases to the atmosphere and changing the world's climate. Ecologists, climate scientists, geoscientists around the world just say, well, we've changed the world enough to merit a technical name for the time that we live in, translated roughly to mean the age of humans, like the age of dinosaurs and the age of mammals. This is now the age of humans. The technical term now is the Anthropocene Epoch. You may have heard of this already. It's basically mainstream science nerd jargon now. So you can impress your friends. If you don't know it yet, here it is, Anthropocene Epoch. That's what we're in. Welcome to it. So another term just to throw out before I go on here is you could certainly ask now, why would this nut up here in the stage be trying to talk about thousands of years of the future, what climate is going to be like, if we can't even predict what's happening tomorrow for the weather or next week and things. I just want to clarify that. I'm not talking about the weather, and you certainly do have trouble predicting the weather far in advance. This is climate. It's a different thing. Weather is a short-term thing that happens where you are and happens here and now, and is very chaotic, hard to understand, but climate is a long-term trend where you average that together and make a broad brush big picture. So I liken it to this kind of thing, where you have a long uphill journey in your vehicle, let's say, going up in the mountains. The upward trip is an upward climate trend, let's say. But you'll have ups and downs along the way, and that's weather. So what I'll be talking about is climate. And oddly enough, if you average the stuff over a whole planet, and over long time periods with a very broad brush, that is actually much easier to predict than the fine-scale weather is. And I'll show you the rationale for what's behind all of this. So to begin on this, we're going to have to change the way we normally think of time scales. And most of us live our daily lives on a relatively short time frame. For a lot of folks, waiting till the end of the lecture is a long time, or the end of the work week is forever, right? But when we talk about climate change, sometimes we say, okay, if we continue as we are now, what will things be like in the future? Usually that kind of a long-term view people take. It goes out to the end of this century. So you'll hear people talking about what happens by 2100 AD if we do this or that. Or you see the graphs kind of ending there the next 100 years. And for most folks, that is a long time period. But realize, of course, it's a limitation in a way, too, if we only think that far. And for someone like me with a geological background, I'm used to thinking on scales of thousands, millions of years. So a century is just the blink of an eye. And the natural question right away for people like me is, well, okay, what happens over that horizon of 2100 AD that sort of blocks our view of the future? You actually can see pretty far beyond that. And what I'd like to do in this talk is lead us up to that ridge and take a peek over there and see what's in the next vast plain that lies beyond that boundary line. So the way this is done is actually pretty common sense, and I think you'll agree then that this broad brush approach does have some validity. This is not my own work, but as a climate historian, I keep up on the modern literature, and this is basically kind of the cutting edge of what's going on in the places where people are modeling the climate. And what they're asking is a simple, important question. They say, okay, first question, where does the carbon dioxide go when it leaves our tailpipes and our smokestacks? Okay. Well, it doesn't just blow off into space. Gravity holds it in the atmosphere. It may blow downwind from where we are, so it seems like it goes away, but it's still here somewhere on the planet. So these folks are basically just following it around like sleuths. And the main place where this stuff goes, it turns out, is into the oceans. Gases dissolve from the air right into the water. That's how fish breathe, right? Oxygen dissolves in there. Well, carbon dioxide does too. Most of the planet is covered by water. So this is the final destination, the final burial place. The water out there around Circular Quay is where a lot of this stuff's going to be going from the air that we've emitted. The question is also, how long does this take? But the first step is, the oceans can hold a lot of this stuff, but they can't hold all of what we emit. There's sort of a balance point that's reached. Once about 3/4, 4/5 of the stuff that we release into the air goes into the oceans can't take any more up. And basically that means what's in the air then, remainder, is stranded above the water and continues to heat the atmosphere as long as it's up there. So it doesn't stay there forever. There's another process. It's this one here. It's chemical reactions with rocks and soils. And I won't go into great detail on this. The basic story is the gas, the carbon dioxide, will dissolve into raindrops up there on the top. And when it does, it makes carbonic acid, little in solution, falls and hits either limestone or granite and reacts with that, crumbles the rock a little bit, and is carried into groundwater and streams in solution. It used to be in the air, now it's in a solution. After reacting with the rocks, it washes downhill and eventually ends up in the ocean again. When it does, in that form, it acts kind of like an antacid pill. Let's say when the ocean's been eating as much of this stuff as it can't eat anymore. It gets this antacid, and now it can consume a little more from the air once that stuff gets in. This takes thousands and thousands of years, because it's a very slow reaction with the rocks, to clean up the rest of this stuff. When it does finally get in, it'll be buried in ocean sediments in the form of just mud or corals or shells or things like that. So it's pretty much common sense. It's geochemistry, easily verifiable. Those are the places where the carbon goes, unless we invest heavily and extract it ourselves somehow, and that's controversial and expensive. If probably this is what's going to be the fate of the extra carbon dioxide that we release from our fossil fuels. And so once you reach that conclusion, that's the ocean and the rocks, and you add it up, we have thousands of years of cleanup coming after this global warming that we're now so focused on. There's a very, very long story here, way beyond 2100 AD. Now, the title of the talk is a term I made up after I looked at some of the papers describing this. And the basic idea is, okay, the stuff's going to dissolve into the oceans and gradually clear up. But a very interesting time is going to be when we switch from the global warming to the recovery phase. And I'll show you another graph in a minute. But it's sort of common sense as well. It's basically the idea that what goes up must come down at some point. So we are going to slow down and then stop emitting these greenhouse gases in such large amounts at some point, either because we switch to alternative energy sources or because we don't and we burn them all up and then there are none left and we have to switch. So that will happen at some point, probably in the next few centuries. So what I've got here is a graph of how much we're emitting. It's going to reach a point and then peak and then start to drop off, either on purpose or because we're forced to. That's what this first bump is over here. There's going up, you're going to have to reach a peak and then drop off again. That's our emissions. Well, when you do that at some point, after the emissions start to slow down, the amount of CO2 in the air will reach a peak, and then that's going to drop off as well. Another peak, like that. And because the carbon dioxide traps heat, you'll also have the global warming we have now. And then it's going to reach some maximum. It's not just going to go until the Earth bursts into flames or something from heat. There's going to be a point that maxes out and starts to drop off. And so you get this successive series of waves of change, going from the rising mode that we're living in now and thinking is the whole story, and forgetting there's going to be a flipping point or a whiplash point where the increase switches into a reverse mode. So like, for example, if you have the temperatures now, we're concerned about global warming right now, and as we well should be, but there's going to be a point, a peak, where it flips, and all of the adaptive strategies dealing with warming are then going to be irrelevant because we're going to deal with the recovery, which is a drop in temperature back down to normal, and that could be stressful too. You may notice this last bump over here too. It's going to be warmer than now, even after that peak of temperature passes, and is going to be recovering. It's still going to be hotter than now while it's recovering. So the ice sheets will still be melting, the oceans will still be expanding, and sea level is going to be going up. So isn't that going to be strange? We're going to have, technically speaking, a global cooling going on back to normal, and sea level is still going to be going up for a while. It's bam, 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 wave after wave. So that's going to be interesting. That's the next chapter in this story. It's a lot longer story than just global warming. So, and this will be the last graph. This is the graph that basically made me want to write the book. This is taken from different laboratories all put together. They all pretty much agree on the story. It's a different time scale. This shows the next 100,000 years of greenhouse gases in the air. It's amazing you can think on that kind of a time scale. But we can. It's common sense, broad brush geochemistry. I'll come over here and sort of run you through the graph. Here's the time scale here. Here's today at 0. There's 10,000 years from now and 20,000 all the way out to 100,000 years. Then this axis right here just shows you how much heat-trapping carbon dioxide is in the atmosphere. So these are units of parts per million. That's not really relevant. What's relevant is just whether it's a big or a small spike. Okay, the star is where we are right now. The air in the room here probably has a little more than what's outside. It's about 390-something parts per million, a relatively small amount of CO2, but enough to change the temperature. If we take the moderate path into the future, where we switch quickly from fossil fuels to non-fossil fuels, whatever they may be, within the next few decades, let's say, then we'll probably end up at the peak of the warming and of the buildup of the gases, somewhere maybe 550, 600 parts per million. So we're sort of committed to some more warming and some more increase here. That's the dotted line on this graph. So it's sort of hard to see it here. We'll jump from this to this. And then the oceans will be soaking this stuff up relatively quickly, and it'll bring this back down in just a few thousand years. But notice this, the dotted line doesn't drop right back down to 0 again right away. The dotted line just keeps going. That's the slow reactions with the rocks and the soils that will take to clean the whole thing up. So even after the ocean takes up as much as it can, this is the slowest tens of thousands of years recovery that we're going to face in the best case scenario for the rocks to clean it up. So this is a lot bigger thing we're setting in motion than what we've been talking about. I think it's important to acknowledge it. It's not a good reason, though, to give up and despair and say it's too late. We have 100,000 years of climate change ahead of us. I'm going to go jump into the water now and forget it. I'm going to sequester myself and contribute to the carbon removal. No, don't do it, because we have work to do. If we don't switch, it's way bigger than that. This stuff, as I'll show you, is relatively moderate, and I think people will be able to deal with it fine. We don't want to just go ahead and do this other thing, because if we just go and burn up what we think are the remaining amounts of carbon and coal, oil, gas, and the methane ices under the sea, that's what we're going to do. That huge spike. That's unbelievable. And that's how much 2,000 parts per million is what you'll get eventually if you spend the next couple centuries burning this stuff. Then you'll get this peak whiplash time there, lasting some centuries, let's say, flipping into the rapid cooling recovery as the ocean takes up as much as it can. Now the ocean is full. And then you have the slow recovery from the rocks and the soils. But notice this, it goes right off the scale of 100,000 years. We're talking 500,000 years to get rid of that stuff. And look at how much warmer it'll be, too. So there you go. It's... Take this first lesson as we are doing very serious things to the climate. Don't give up because we have work to do. We're going to hope we don't do this. So I'm going to follow this up now with some historical examples of what happens to the world when this happens. And it turns out we've had both of those situations happen in the geologic past before. Just sort of my specialty. So what will it be like in these two scenarios? And I'm going to focus mostly on the peak warming time here. What would it be like in the worst case, right on that whiplash time? So let's take the moderate case first. There's a little graphic from that Ice Age Meltdown movie some of you may have seen over there. It turns out that relatively moderate warming case would probably bring us close to what we've seen in the relatively recent geological past. We've had dozens of ice ages in the last 2 to 3 million years just from natural cycles. And in between each of those, we've had natural global warmings. Kind of like when the Earth comes up for a breath of air between the ice ages and all the mammoths fall in the water and stuff like that. So last one we had before the last ice age was about 130,000 to 117,000 years ago. It got 2 or 3 degrees warmer on average around the world. That's about what we would get from that moderate warming if we switch quickly to fossil fuels. So what would that be like? Well, we know because we have the rock records that tell us. So, for example, in the last interglacial time, if you traveled to Britain, those are the White Cliffs of Dover, you'd see elephants walking around and hippos. There were water buffalo in Germany drinking from the Rhine River. Basically what happened there was African tropical type of animals moved north because it was warmer up there in northern Europe and England, and they died and left their bones there. You can dig them out of the middle of London when they're doing repairs on the roads and things. So that would make sense. As the climate belts moved warmer towards the poles, animals moved with them. If you went to the inner tropics, let's say the Sahara Desert here, as you warm the atmosphere, more water evaporates into the air from the oceans. So when it rains more. And also you heat up the tropics, the air circulates more, and you get more intense monsoons. So when we had this warming, the Sahara Desert was green and flowing with water. Where Carrie and I live in upstate New York, we have kind of cold climate forests, lots of pine trees and things like that. But at that time, if you look at the pollen in the lake sediment deposits, there were trees from the southern United States, oaks and hickories and things. The forest totally changed. Basically, the climate belts moved towards the poles. Then, because it was warming, you had melting of the high latitude ice sheets, too, just like we do now. An important thing to recognize, though, while we hear how rapidly Greenland is melting, and it is, and the West Antarctic ice sheet, how rapidly that is, we often forget how large those ice masses are. So even though you have this rapid melting, it takes a long time for all of it to go away. And through that more than 10,000 years of warming in that last interglacial, only between a third and half of Greenland melted. From being warmer than now for 13,000 years. So keep that in mind. Sea level came up quite a bit. I'll show you a quick picture. But not all of the polar habitats disappeared. Polar bears made it through this, even with thousands of years of warming. Around here in Australia, and here's South Africa here, you can see old coral reef deposits way above water level now that date back to that last interglacial warm period. So you can see that sea level came up 6 to 9 meters higher, let things live, and then that sea level has dropped since then. These are fossil oysters near Durban in South Africa. So the point here is this is not science fantasy that sea level can come up that much and that the world can warm. We know it can happen because it happened before. There are clear historical examples. Well, oddly enough, even the extreme worst case scenario has examples from the geological past too. This has also happened even in the absence of humans. If you go back 55 million years, just some time after the demise of the dinosaurs, there was a partially unexplained, massive, rapid warming spike. Probably from maybe these methane deposits in the deep sea. If you may have heard of these frozen methane ices under the deep sea, you can build a snowball out of them and light them, and they burn as they break against the wall. Probably from volcanic activity in the deep sea setting these off, there was a burst of carbon dioxide into the air, much like what we could do. When that happened, all of the polar ice melted. The Arctic Ocean up there was completely ice-free. There were forests all around the poles. You could swim up there in the summer without a chill, probably, if you traveled back in time. We didn't have modern mammals then. This is 55 million years ago. So back then, whales had legs. And these predators here had hoofs on their toes, but then they had fangs. It was strange mammals. So we don't have examples of what could handle that. But they thrived on land, anywhere from the tropics up to the poles. It was lush vegetation everywhere on land for wildlife, and they actually did well. If you went to Antarctica, there would be dense beech forests. If you went to the Arctic, there were dense redwood forests all around the Arctic, and you can still find their fossils, and in fact, not even fossils, but the actual mummified tree trunks from these things still there from that time. With it being that warm, all the ice melted. So if we had had polar bears back then, they wouldn't have made it. When you get rid of all that ice, you get 70 meters of sea level rise. Here's what the world's continents today would look like if we did it again. So I'm not sure how good your geography is, but today and in the States, we have a state called Florida that sticks out there. That would be gone. I'll actually show you a picture of Australia with a big hole in it later, too. So that's what would happen. That's what we're facing. It's not science fiction. It actually happened before. And so it could certainly happen again with our help on top of it all. So to now sort of back off from this, we've shown what the two extremes would be like. The bigger picture is beyond the warming phase and the peak time, there's another set of changes coming after that. We're used to thinking of warming and of glaciers shrinking back up, and that's very concerning, of course. But just remember that afterwards, as the recovery happens and people are used to having it be that temperature, as it recovers, they're going to experience that as global cooling. And that'll be stressful. And if you happen to build your towns near glaciers, if there are any left, and they start to grow, that's going to be scary too. In fact, it was in recent centuries when we've had natural coolings and alpine glaciers consumed villages in the Alps and things like that. So we're going to have both of these. As far as people and other species go, the strategies to deal with this are mostly going to have to do with adapting to a changing environment. So if you're a coral reef thing, you're going to have to, keep pace with the rising sea level, and then later the adaptive strategy is going to flip, and you're going to have to deal with falling sea levels. And same for salt marshes. It's a lot more to this long story than just the introductory chapter we've been talking about. So now to sort of draw another lesson from this historical example, we've had the moderate case before, we've had the extreme case before. As you saw, even in the extreme case, a lot of land animals did fine. There was vegetation from pole to pole, and you could say, oh, that's great, There's a big difference. Number one, if you do the extreme, you wipe out all the cold habitats, so biodiversity went down. But the other thing is, there's a new factor in the equation today. We are in the Anthropocene Epoch. We are here in huge numbers. Our cities, towns, roads, farms are confining the landscape So the main adaptive strategy, which is migration, is constricted now for animals and plants. It's difficult for them to move as the climate shifts under them. So now will be a lot more difficult time for other species than it would have been from these natural changes of the past. So it's important to realize that. Yes, it has happened. Yes, they adapted, but not with us in the picture. Then also keep in mind, and I think this is the low point emotionally of the whole thing, is like how terrible it's going to be. This is the worst. This is the other reason I wrote the book. There's more to it than climate change with this CO2 we're releasing, and we don't hear so much about this. Climate will warm, then it'll recover. There will be parts of the world that you could argue are more habitable from warmer climates. But there's another aspect of this whole story. It's that when the ocean takes up the carbon dioxide, the CO2 dissolves in the water, it makes carbonic acid. And that upsets the chemical balance of the oceans, such that if you're a marine organism that has a hard part that can dissolve, any of the shellfish, prawns, crabs, corals, that stuff dissolves. We already see the process happening. It's called ocean acidification. So oddly enough, the climate recovery process will include a chemical disruption of the oceans that has the potential to wipe out many, many marine ecosystems. As I said, it's already being measured, happening now. The more we emit, the worse this will get. Most of the extinctions could well happen in the oceans. So it's important to keep that in mind. But don't go jumping off a bridge yet. Next question is, who cares? All right, well, I'm a biologist. I'll automatically care about the other species. But what if people aren't around in 100,000 years anyway? What's it matter? And if you don't mind, I'll do another quick survey. Let's see if we get the same result. How many of you would think that humans will even be around in 100,000 years? Or even in 1,000 years? We're not supposed to get through 2012, right? That's when the end of the world is. How many would say you think humans will be here in 100,000 years? And how many would say no? Probably not. Yeah, okay, that's more what I'd expect, about half. We don't have time to get into it in huge detail. I will give you my case briefly and talk to you afterwards if you want, why I think we're going to be here. And I think it really matters because I think people are going to have to experience all this stuff we're setting in motion, and so we do have an ethical reason to be caring about this stuff. I just figured, well, what could kill us all off? Now remember, this is total extinction of humans. Not population decline, not suffering here or there. I mean, like total planetary wipeout. I say there will be some people somewhere getting through all of this and experiencing it. Okay, I just made a quick list. Those are the three big ones I think could take us all out. You could have things like bubonic plague. Okay, that can be very terrible. We're worried about plagues. You could devastate half the planet's population or 2/3. But even when the Black Death decimated Europe and half of all Europeans died, we hear about that huge number. You forget that means half of all Europeans survived, even without modern medicine. So there's a thing called natural selection that happens with diseases. I think some of us would probably pull through even the worst diseases. Fingers crossed, I hope we don't have an all-out international full global nuclear war, which would be required to wipe us all out. When I was growing up and afraid of war with the U.S. and Russia, we figured you Australians would be the ones left behind, because it wouldn't get down here in the southern hemisphere. Right. So let's hope people don't do this. It would have to be a gigantic all-out thing. As far as asteroid impact goes, yeah, a big one hits us and it melts the whole surface of the planet. But astrophysicists I've been reading say there are none large enough in the solar system likely to hit us in the next 100,000 years that would be big enough to wipe out the whole human species. So that's the good news, right? If you believe me, wow, a bright spot. Notice I didn't put climate change on the list. I'll give you two reasons why. Number one, it's a very serious problem, as I'm obviously presenting. I don't think it's a deadly threat to human species because, first reason is my kind of research. I look at climate changes of the past. Here's a recent study. Let me just show you what people have been through, even without technology. This is Stone Age people, 17,000 years ago, in virtually all of Africa, and the entire southern reach of Asia. The entire monsoon region has climate records where all those red dots are, showing that there was one of the most intense, long-lasting droughts of the last 50,000 years or more struck that region. It probably didn't rain or rained very little for hundreds of years. And people lived through it, even with Stone Age technology. There was probably population declines. The genetics of people in India, for example, show a drop in population then. But somehow they pulled through. So we are incredibly resilient. So I think it's unlikely that global climate change will get us. And here's the other reason. There are parts of the world you could argue will become more habitable to people. And one example is places like Greenland. It's covered with ice now. Nobody lives where the ice is now. And you ever ask yourself, what's under all that ice in Greenland? Well, people are looking. You take radar measurements through the ice and you map the bottom of the bedrock, and here's what you get. If you take away all the ice, you get this fjord. It's below sea level. The sea will come in. It'll be a protected harbor right in the middle of Greenland. It'll expose mineral deposits. They've got all kinds of gems and metals that are valuable. By then, the Arctic will be ice-free. There will be giant fisheries up there and trade routes. You could argue that if anybody is going to win from global climate change, places like Greenland could very well benefit in the long run if you added it all up. And even if the rest of the world is suffering, some people would survive there. So that's my case. I think people are going to be here. I think that makes a strong reason to take this whole giant 100,000-year time scale seriously, because it's going to affect people as well as other species. People will live through it, which means people will live through this stuff. All right, so some will lose, some will gain, as I sort of alluded to here, and then the trends will reverse. It's a giant, complicated, interesting situation we're in. I'll just give you a few examples just to show you the changes that are already in motion. Like you hear about the iconic polar bears, they're declining because the ringed seals that need the sea ice are declining as the ice retreats. What you don't often hear, though, is the loss for these folks is an opportunity for others. And it turns out harbor seals are moving in where the ringed seals were. They're coming up from the Atlantic and the Pacific. The brown bears, the grizzly bears, are moving into polar bear territory to the point that they're hybridizing with the polar bears. Here's a hybrid Pisley or polar grizz right here that was harvested several years ago. So one species loss is another one's opportunity, and that's going to be happening. It's a lot more complicated. You have the ice-adapted belugas and narwhals up there in the Arctic, too. And they notice they don't have the big dorsal fin because they're bumping up against the ice all the time there. As the ice retreats, these are starting to decline, and orcas are moving in from the Atlantic and the Pacific. They have their problems down south. This is a great opportunity for them. Notice they got those big fins there. They now, with the open water, they can go in, and they like to eat belugas and narwhals. So the whole ecosystems are changing. They have amazing, wonderful, ice-adapted communities with all the plankton and the small critters and the fish. Those are going to be disappearing in the summer. At the same time, you can already see it happening. Without the ice, the sun hits the water. It makes other species of plankton grow, and other species of fish are moving in. There's going to be a giant fishery up there. I'm told that Russia is already building the fishing fleet to take advantage of the whole new ecosystem that's forming up there. So if you doubt that the Arctic is opening up and that climate change is happening, talk to the folks that are investing up there already. And talk to the folks that are going into a giant land grab up there. I don't know if you've heard about this. Maybe you heard that Denmark and Canada almost started a war recently over this little chunk of rock in the water between Greenland and Ellesmere Island, called Hans Island. The boundary lines had never been resolved because no one cared. Now that the Northwest Passage and the Northern Sea Route is starting to open up so you can connect Asia with Europe by sea routes, that's strategically and economically important now. So the Danes would come to this island and want to claim it for themselves so you can have the hundreds of miles of ownership around it in the shipping lanes. So the Danes would come with a gunboat, put up a Danish flag, put a bottle of schnapps at the bottom. Little sign says, "Welcome to the Danish island." And then the Canadian gunboat would come over, knock over the flag, drink the schnapps, put a bottle of Molson's, probably another sign, and back and forth, and almost started fighting over it. You may have heard that the Russians have claimed the North Pole. They put a submersible under the ice, planted a titanium flag on the seabed under the ice on the North Pole. because then if they claim that, they can then have the mineral and shipping and fishing rights around the North Pole. So anybody that doubts this is real should go and talk to the Russians, Danes, and Canadians that are investing in this. All right, so getting close to wrapping up. Facts and speculation. I'm hopefully sticking to facts here. We will quit fossil fuels at some point, either on purpose soon or by burning through them and switching. So this is going to happen. How we do it will influence the world for thousands of years. And that's the new information, the take-home lesson. This is a much bigger thing than what we thought. Some will gain and some will lose. That's true. And then the trends will reverse, and the winners may become losers. It's a gigantic, huge thing we're setting in motion. How do we weigh the good and the bad in this picture? Maybe it's good in the long run, right? How do you tell? But we haven't even been thinking on these time scales long enough to have those answers. So let me just raise a few of them, just sort of for interest, okay? One thing I would venture to say is among the losers will be this wonderful place. All of the climate models agree on one thing, and the climate records that I study agree with another thing. When it gets warmer, the winter rain belts tend to shift closer to Antarctica. My research in South Africa shows this, and I was just working in Perth. It looks like your lake records show the same thing. These rains pull away. They don't hit the southern tips of those continents anymore. You're likely to get drier in the long run. So get ready for that. I'd say it's probably mostly negative, unless you lived in Brisbane during the floods. But I think in the long term, that's going to be more of a problem. The sea level rise is a problem, but keep in mind you should temper that a little bit, not be fooled by the slow pace of it. Oftentimes we hear it's going to drown you, it's going to flood New York City and Sydney like that. It's not going to happen that fast. It's not like you're down at the beach, you put the kids on the towel, you go get them an ice cream, you walk back and they're gone. It's not like that. But it's huge. Okay, so it takes hundreds of years or thousands of years to make these maps happen, but they will happen. So it is very serious. And so you can ask yourself, what's it really going to be like to be in these cities and places like this, right? Well, probably more like this. We've already got examples around us. Sea level has been coming up, and the ground has been sinking around Venice for a long time. That's how they deal with it, is the city really does look like that. And it's a slow thing that's sort of a chronic problem more than an acute disaster. And, of course, some of you may have actually paid to go look at this and have a good time there. I've never been there, but I would kind of like to. There are other aspects of it, too. You could argue that while the cities that are on the coastlines are going under and suffering from that, things that we joke about by saying, oh, well, let's buy property in here and it's going to be oceanfront property and pretty soon. Well, that's true. And some cities inland will probably see that coming and say, well, we'll have a century or two of an economic honeymoon for a while. Let's get ready for it and enjoy it while it lasts, you know. And that's actually happened. Like Amsterdam here, centuries ago, was completely landlocked. Slow sea level rise came up after the Roman times and gradually burst through here and flooded this and made a harbor and turned this into a port city and gave it all those great economic opportunities, which it took advantage of and made it an important city in history. So that's the other side of the sea level rise thing. There's going to be the ones going under, the ones having their little honeymoon, and the ones anticipating it, and it's going to be moving back and forth. And then back the other way as the sea level drops again. All right. So 2 more quick examples, and that'll be the end. Let's see how we're doing. Oh, yeah, this will work. This is kind of a strange one here. Again, as you look on these time scales, and not just think about how we are now, what we think of as unthinkable will become normal on these kinds of time scales. And then when the reversal happens, it's going to be a completely different story. So I've got 3 time slices here. Here's the world as we see it now. There's the north with the ice cap on the Arctic there. Within this century, almost certainly, it's going to look like this in the summer, without ice on it, probably in the next few decades. And it's going to stay like that for thousands of years in either case. Well, you think about that. If it stays there for thousands of years, that means new ecosystems will be developing up there. New cultures are going to co-adapt to that and become established, and they're going to be there for thousands of years. Imagine cultures and ecosystems thousands of years old forming up there. Then it will be normal. Then, when the recovery eventually brings the temperatures down enough for the water to start to refreeze, they're going to be threatened by that on these timescales. It's mind-boggling to think of this. What we think of as unnatural, they're going to think of as normal, and getting back to the way it is now will be seen as a disaster. Like imagine the elders going down to the shoreline in the morning up there on a chilly morning in winter, and oh my gosh, there's ice along the shore of the... Oh, I've never seen that as a kid. What if this continues? What if the whole Arctic Ocean freezes over? We would be destroyed. So this is what happens to you if you think of these time scales. So as you can tell, that's why I'm so weird. Hope you're not permanently affected by it. But here's the last one. This kind of a time scale brings you to my specialty, was the coming and going of ice ages and natural climate cycles. We actually know how the natural cycles work. We can use it to predict when the next ice age would be. And all things without humans on it would say that you could follow this graph of temperatures up here from 0, which is today, tens of thousands of years, so you get a dip about 50,000 years from now in temperature in the Arctic when a new ice age would start. Now, if you remember, even in the most moderate scenario, our greenhouse gases are going to be here through that whole thing. They're going to raise the temperatures just enough that if you balance out the temperature changes, the Earth will be unnaturally warm enough at that time, 50,000 years from now, to cancel that ice age. We have stopped the next ice age just by driving our Humvees around, basically. And if you think about that, that's pretty amazing to have that kind of an influence. It's also kind of interesting if you're from Canada or Northern Europe and you're sympathetic to that part of the world. Imagine having a sheet of ice a mile or two thick bulldozing your entire country. And that's what an ice age is. That's total devastation for tens of thousands of years. So if you want to be really cynical about it and maybe get a chuckle, you could say, well, maybe people in 50,000 years would be glad that we've stopped that ice age. So anyway, I don't think that balances the equation out to a net gain. But this is what you get when you think in these large time scales. And the most amazing thing is that it's true, basically. This is what we're really doing. Now, the point is the cycles are going to start another one in 130,000 years. If we do the moderate case, then there will be an ice age in 130,000 years. The only good thing about the extreme scenario is it will stop that one too. So there you go if you're trying to add up the pluses and minuses, right? All right, so how do you make use of this kind of a thing? We want to save the planet, we want to save the whales, we want to save the world. Maybe with this long-term view, if we really take in these things that I was introducing you to, maybe we can use that information to look for win-win strategies so one time period doesn't have to suffer as much as the other one and one group of people doesn't. Hopefully there are a lot of good reasons to switch to alternative energy sources. Even then, the climate change, for those of you that don't believe in the climate stuff, plenty of good reasons to switch away from petroleum as we're running out, just for energy security, the cost of the stuff and things like that. Everybody's got their own favorite alternative energy source. I'm actually a former nuclear protester from college, and I'm not that much into uranium stuff, but I would encourage you to look into this, which I've had engineers tell me about, and maybe it's as good as they say. You may have heard of Thorium Power, which is a new kind of nuclear power. It runs on thorium instead of uranium. If these people are right, and they call them green nukes, basically. If they're right, they say they can't melt down. You can't use them for making weapons. The waste is relatively benign and short-lived. It's cheap and abundant. And you can use it to burn up the waste from nuclear power plants and weapons programs. So I asked them, what is the dark side? There has to be one, and they tell me there is none. I don't believe them. Hopefully you will look into this and try to keep them honest, as I'm trying to do. Anyway, there may well be alternatives that can help us do the right thing, even if you don't believe the climate stuff. So I think there's hope there. But sort of with tongue-in-cheek, to bring you back to the long-term view, Carrie and I here came up with one more good reason to leave the carbon in the ground and not burn it so you can save the planet. We call it save the carbon. Leave it in the ground. Save it for later so that later on, when the ice age is threatening, if our descendants decide they want to do it, then they can just set some coal deposits on fire. Then we don't have to decide for them. We'll head off the most extreme climate and economic disruptions in the near term, leave the option in the ground safely and naturally sequestered for future generations, and even if they're low tech, all they got to do is climb the mountain here just north near the city here that's been burning for 6,000 years. Has anybody seen that? I'd love to see that. It must have been a lightning strike on a coal seam, I guess. Here's a coal fire on a coal mine in China. Just light a few mountains on fire. Release the CO2 into the air, stop the next ice age. So, anyway, the good news is humans will survive, if you believe me. The bad news, many species may not. This is the Anthropocene Epoch. They're going to have trouble migrating, and the more extreme our effects are, the fewer of them are going to make it. So I'm more concerned about other species than the human species. The reality is we are going to decide this climate future, either by acting or by doing nothing. It's going to happen in the next few decades. We are incredibly important in the grand sweep of human history and Earth history. It's an amazing time to be alive, to have this kind of influence on the deep future. So, to wrap up, you are a force of nature. We're so numerous, our technology is so powerful, we're so interconnected that what's in our heads affects the life and death of species and people and climate for millennia into the future. Therefore, if you are well informed, then you can ask good questions, choose the good ideas and solutions, and not maybe be sort of swayed by the back and forth that goes on and seems to distract us from these incredibly important topics. So with that, I welcome you to our deep future, and thank you very much.